Mette will now be joined by Tor Henning Molstad from the Nordic Additive Manufacturing Group. They're going to be talking about AM production for maritime and offshore industry in a DNV qualified process. A result of their teamwork, they will be talking about pioneering standards in AM, about their collaborative efforts, and highlighting some of the innovative industrial applications. So showcasing some practical outcomes such as 600 mm diameter and 100 kilogram plus impellers for offshore pumps and water jets. So over to you two, thank you. When we have a screen.
Yeah, but it sounded great when you told us.
Okay,
so
thank you.
It seems to be an interesting presentation.
I'll stick around, thank you.
Thank you everyone for joining us this afternoon, late this afternoon. I have invited some friends, just to be sure I'm not here alone. You're able to fix the screen for us? I'm glad to have the possibility from a small company in Norway do this presentation together with Mette Nedreberg from Kongsberg Maritime. That's a big company compared to our small company. And we are going to talk a little bit about our company. I will present our company first. And Mette will talk us through a couple of projects, two products we have been developing together in some projects in a qualified process. And at the last, I will tell a little bit about an impeller which we have produced together with Eureka for the customer Equinor in a qualified process, in the DNV qualified process. Nordic Additive Manufacturing is located in Norway, Raufoss Industrial Park. We have very close ties to SINTEF, that is a research institute, and also the local university. And as you see in the ownership, we have both SINTEF on the owner side and also Nammo, which is in the defense industry, and some small industrial investors. Our technology is laser metal deposition, and we are only concentrating on laser metal deposition so far. With LMD, we can repair, we can build new parts, we can make changes and also improve existing parts. And we say that we do additive production in a revolutionary way. And it gives possibility in a multitude of combination of materials. And you see some examples in the bottom of materials which we have been tested. Yes. We are using Siemens NX both on CAD/CAM. Gives us the possibility to produce advanced geometry. And we have had a tight collaboration with the Norwegian supplier of the software for being able to do this. But it all started with repairs. For us, it started with repairs. You see some impellers here for Equinor, both in steel, 316 steel, and also in aluminium. And some examples with the shafts for pump shafts, where we have been doing repair. This is in duplex material, 22 chrome. And also repairs like this in alu bronze for this old steam dumper, steamboat going on over local lake. This is in aluminium bronze. And now Mette will talk us through a couple of projects.
Yes, so together with NAM, we had made two quite good components, I think, and we have also here tried to follow the guidelines from DNV. So we have in fact had an EU project, we call it Fleximan, and we chose to make a water jet impeller in duplex material with this LMD method. And the scope was to improve lead time, improve quality, and reduce cost. So there are some standard requirements for this material, but in addition, we also had some Kongsberg Maritime requirements regarding microstructure, porosity, also fatigue is important for a water jet impeller, cavitation erosion, and also lead time and cost. So this impeller was produced by NAM and also heat treated. So we followed the guidelines from DNV. This is a critical part, so we had to use this AMC3 rules. And we had to make this block, and in addition we had to make a representative part as we have in the critical part of the impeller blades. And we did a lot of testing, and the results were very good. So all properties were better than the requirements for this part in all directions. One very good news about this was the cavitation erosion testing. Because this impeller is very high loaded, it's a very high speed propeller, so we have some problems with erosion in this casted duplex material. When we compared casted duplex with bronze and also this printed material, it seems like the LMD material has better erosion properties than the casted, and that is a very good thing for our impellers. And also fatigue testing, we have this fatigue limit, our stresses is below, so it's also on high cycles and the actual loads, the properties are as good as casted. So here you see the result of the printed impeller, the machined impeller, and also the geometry of this impeller was very good. What they say in the production in Finland is that they should maybe given some tighter tolerances, because they were some skeptic to this low tolerances that they could give, but so they know that next time they will maybe...
Yeah, we can decrease the machining allowance on the next water jet impeller.
Yes. And also porosity, there was some small porosity, but still within the requirements from the class society. The next part is we have this in Kongsberg Discovery, we have this unmanned surface vessel, which is doing a lot of research in the oceans. It's filled up with a lot of equipment, sensors, and so on. So they have only bought a standard propulsion system for this vessel. And since it's autonomic, it has to last as long as possible. So even if they use diesel or electric energy, they want it to last or to run for as long time as possible. So this propulsion system is not optimal. So we did a design optimization of this propulsion system, did CFD analysis and strength calculations, and we made in fact this propulsion system now in glass fiber, but a 3D printed propeller with NAM. Yeah, so here you see. So it went very well. The microstructure is quite nice, and the mechanical properties is in according to our requirements. So here you see the result as printed, as machined. In the factory, they were quite happy with the result. They were showing around this nice propeller, and they did also penetrant testing, and there were no porosity. So you see the happy team here.
We are ahead of schedule, Mette.
Okay.
It goes fast.
Yes.
The next project is a project together we have been doing together with Eureka. Eureka is the OEM for these products, and Equinor is the customer. And it's all about energy optimizing of a big seawater pump, lift pump. using additive manufacturing, laser metal deposition. The scope of work was like this. In fact, this pump, it pumped 1,000 cubic meters too much every hour. It wasn't so important when you produced the power out on the field. But as you might know, it's going out with the electrical power out on the fields now, and it will be more and more important to do this kind of effectivization. And you see a little bit about the CO2 energy reduction in the bottom of the screen. This is quite big products. It's 45 meters long, this pump structure. And you see the platform it's used. There were some expected challenges in this project. The size of the impeller were 120 kilos per impeller. It was 3 impellers. It's a very complex material, the 22 chrome duplex, and it also was regarding to NORSOK qualification. NORSOK is a standard for the Norwegian shield, what you call it. It's out on the Norwegian shield. And it was also a qualification according to this DNV GL, the new standard B203, AMC2. And what's my thinking of a project like this is that it was very important with the collaboration of the involved parties. The collaboration with the OEM, Eureka, and our team in NAM, but also with the SINTEF, the research institute, with the laboratory and the test facilities and so on, and also DNV. With DNV with this new standard, also developing the standard going through the project. And Equinor as an end user of the product. It went well. We managed to do these impellers in a qualified process. We did the qualification regarding and according to the standard. But it wasn't without a fight and some struggle. We spent a lot more time than scheduled, and also a lot of effort to do this. But in February this year, or in the end of January, we delivered 3 of DNV qualified impellers, and each of them is 100 kilos machined. And it's never been done in LMD process, qualified process before. This complex geometry is one thing, but the complex material is another thing. It's a austenitic ferritic material. It's very important with the heat treatment, the building parameters, the speed, the power of the laser, and so on and so on. So we had different attempts in the strategy on building the impeller, but we succeeded in the end. So and Siemens NX was an important enabler for doing this complex geometry. And again, I mentioned this tight cooperation. Here is from our machine, which we used for this product. It's a Trumpf True Laser Cell 3000. It's from the heat treatment. We don't have our own heat treatment on this scale, so it's a company close by that did the heat treatment. And they have new equipment from Ibsen in Germany, very good equipment for this kind of heat treatment. As Mette showed us with the propellers, the test and the verification for qualification was very, very important. With these fatigue tests, the tensile Sharpie, we have to test on minus 46 centigrades with this Sharpie V, and it's very, very strict and tight tolerances for the materials. But during the project, we qualified the process, qualified the parts, the part family. So now we are ready to make more of products like this. And this is from the factory acceptance test together with Equinor and Eureka. Eureka has very good facilities for testing this kind of pumps. I believe you have 60 meters depth, Jone, yes, on Sørumsand. So they can test these pumps in full scale. Very, very interesting. And being here together with Equinor and look at the tests, and the tests was better than planned. So that was very good. It was slightly lower vibrations. They had slightly lower power consumption than calculated. So the AM-built impellers was a success. Lucky for us. We are a part of the Nordic Pavilion downstairs in Hall 11. And you can see the pump impeller on this booth D68 downstairs. So go by and have a look at the impeller. You can contact us, Nordic Additive Manufacturing, on post@nordicadditive.no or at LinkedIn, or you will find us if you want to reach us. Thank you.
Thank you very much, both. Any questions?
Yeah.
Any questions to end the day? I know it's late. You've all been an excellent audience. Thank you very much.
Thank you very much for the presentation. For this part, I would like to ask, is there any internal CNC machining?
No,
I mean,
not any internal CNC machining. Earlier, I have made a lot of foundry patterns for a product like this. So the other technology they use is castings. So we have been using some acid washing and just some mechanical grinding. But almost nothing inside the Jone. Eureka, the OEM, is over here. So no machining inside.
is it the same for casted parts?
Yes,
Okay.
it will be.
Okay.
But they can coat the cores and they can do something with the sand cores before they put them in the mold. So,
Thanks a lot.
yeah.
Thank you very much. Also from my side for the presentation, I would ask, if possible, could you indicate by using that new technology, a combination of that new technologies to produce these impellers, what is about the cost reduction comparing that to a conventional production method?
This impeller will be more expensive than a casted impeller. But I didn't mention it, but if you send me an order for a pattern, foundry pattern, I will have 10 weeks before I deliver a pattern to you. And in Norway, we don't have any NORSOC qualified foundries, so we'll send the patterns to Italy or Portugal. And even Equinor is a small customer when it comes to castings. So it can take 6-8 months before they get these casted parts, and then it goes to machining and so on. And you always have it might be pores, or it might be some faults with the castings. It might be, and then you get this all over again. So thank you. Thank you.
Okay, any further questions? No? Thank you both very much.
Thank you.